everyone. Welcome to today's webinar with the topic Pressure Calculation Tool. As usual, we are happy to answer your questions via email. For that, please send us all your questions to sales@tsurumi.eu. Today's topic is to show you how we will proceed with calculations in the future and how we can support you with them. And today we will not only show you how to select the right pump. Our focus is today on the design of dewatering systems. This means that we will move from the individual pump selection to the complex design of dewatering systems. So the topics consist of two main parts today and will take about 20 to 25 minutes. In the first topic, we want to talk about pressure in general. In the second topic, we want to talk about dewatering systems, which mainly dealing with the sub-items of project information, request data, technical specification, and the initial selection criteria, technical data, especially with focus on the basin and focus on the pipeline or piping. And at the end, if spikes should work, then we want to try once again how to select a pump. So let's get started with the first topic, pressure in general. Today, I would like to briefly repeat the term of pressure in relation to pumps. We have already talked about it in the past, but today we are changing the perspective a bit. If we talk about pressure, we think primarily of the head of the pump when we see a picture like this. Let's think for a moment why that is. I assume that every one of you still knows the term water column. If we talk about water column, then we always have in mind that 10-meter water column corresponds to approximately 1 bar pressure, which according to the old unit corresponds to about 100,000 Pascal. This can be illustrated with an example very easily. So for that, let's have a look on that sheet. We see that the pressure in the formula depends on several items. The first one is the density, then the height, and the gravity acceleration. The size of the face or of the surface where we or what we have in mind, it does not matter. So let's check the numbers. Let's count or calculate with a density of 1,100 kilogram per cubic meter of the medium. Let's take 10-meter water column, and then we will see that the pressure, the calculated pressure is 1.08 bar. Actually, the gravity acceleration is 9.81 meter per second squared, and normally we calculate with 10 to make the calculation easier. So that would mean instead of 1 bar, we would have here 1.1 bar. So what is the reason for this? This is very simple to answer. It is the density of the medium. If we change to 1000 kilogram per cubic meter, then we will see the number at the end will change. And if we use at this stage 10, oh, sorry for this. Was the security, high security level at TG. So then we will see, we will get 1 bar pressure. If the density is higher, that means if the density is higher than the density of the water, then the gravitational pressure of the water increase, and thus the pump needs higher capacity to pump a special volume of liquid. So this can be also very easily illustrated on this side. Here we can see once again 1000 cubic meter per kilogram. Of course, we will have here additional data. The head we can change to 10 meters, and let's calculate this 50 cubic meter per hours. So the pump delivery capacity is at this stage at 1.5 kilowatt. So what will happen if we change the density? Let's change to 1300 kilogram per cubic meter. We can see that the pump delivery capacity will increase. And what we also can see at the bottom, that the required power input also increases. When we go back to clear water with 1000 cubic meter per hour, then all the numbers will change again. So now we need only 1.36 kilowatt. This calculation is a little bit complicated as before on the first page, because the density, not only the density will have a big impact on the calculations, also the flow rate. So what will happen when we increase the flow rate? Then all the numbers will change again. That means the pump delivery capacity and also the required power input. So let's make a brief summary. The head of the pump in the diagram indicates that the pressure of the operating point of the pump. So the higher the density, the higher the gravity pressure of the medium, and the more power requires for the pump. Accordingly, this assumption also applies to the flow rate. Good. So this brings me to my second point, calculation of dewatering systems. So for that, we will switch to this slide. I want to start with the project information. Why do we need those? It's quite simple. The calculation that will be proceed by the technical department will be stored centrally so that they are accessible to all our colleagues at TEG, and so that they can follow up the history and gain new insights from the calculations. That is very important for us all to learn a little bit more about. I see we have got a question. This platform is from Spike's program. No. This is not from Spike's program. This is a separate calculation tool. I will comment that point at the end of the webinar, if you agree. So, let's start with the main information. The name. I would like to explain what kind of info we expect from you all. In that field, it would be nice to have the name from our partner or from our colleague, an email address, an inquiry date, the name of the project, if possible, a project number, the revision number, etc., etc. Site information, where the pump or the pumps should be installed and where the end user is. So far, we have talked about pump selection. Here we are talking about the design of dewatering system. So that's why we need to collect much information as possible. So, and for the personal information, we have especially various reasons. But first of all, in order to protect territorial issues. So, but why is it important to have this info? This is necessary that we can offer better solutions with which they or your customer can work better and safer. And in addition, we can improve the CO2 footprint with an optimal solution. So before we talk about the rest of the information, we can see on the left side, fluid, temperature, density, viscosity, all this information will have an impact on the whole design. You will have the possibility to select some topics, especially in this area. What kind of operation do we talk about? Containment or in the fluid, etc., etc. What will actually happens if the pump in the system have been selected incorrectly? This is a very important question. So is the pump too small? It will either be overloaded or the basin can be flooded. If the pump is too big, then cavitation can occur in the piping system, or the pump switches on and off too often and can be also damaged. Here we actually only need the technical data we always ask for in the technical department. Therefore, we kindly ask you in the future to always include this technical data in your communication with us and also with your partners and customers. Of course, we would like all the information in the list, fill it in, but we know that it is not easy to get all. Therefore, leave the fields open where no information can be obtained. So let's have a further look at the fields. Since we are talking about dewatering systems today, I would suggest to start with the basin, because we can already calculate here whether the concept will work or not. And that means we will start with the incoming flow rate. We can just select 60 cubic meters per hour. And then we have to define the size of the basin with, as example, 5 meter to 4 and 5 meters. So then we will get the total capacity of the basin. Then we have to define two very important points. That means the min level and the maximum level. Why do we need this? We need a minimum level to avoid that the pump will work under slurping conditions. And with the min level, we can guarantee that the pump will switch off in good time. So with the max level, we want to avoid an overflowing of the basin. So that system will immediately calculate the time you need to reach the minimum level at 60 cubic meter per hour inlet in the basin. Under this condition, 90 minutes will be needed to reach the maximum level. So, and between the water level, between the min and max level, we'll need 80 minutes to empty with the pump. So under these conditions, but this is not really true because we still not have defined, oh, it is true with 80 cubic meter per hour. Sorry, there was a number already. So what will happen if we change this number to 60 cubic meter per hour outlet? So we still need 80 minutes. So this is the time of unloading of the basin, of the net capacity. Net capacity means the level between max and minimum. This system automatically calculates the number of switch on and switch offs after the initial start. That means if we started the pump at minute 0, the pump will operate for 80 minutes. Then there is a short list we need to use if we want to consider, or if we need, or we need to consider the cool down period for the pumps after switching off. So in that case, we need to consider additional 50 minutes. So the second switch off will be after 95 minutes. This is due to Tsurumi defined the maximum switch on and switch off intervals are limited to 3 per hour. So what will happen if we change some numbers? When the incoming or the inlet flow will be increased sometime due to several reasons, but we cannot change, or the pump will not be changed, then we will get immediately an alarm because the incoming flow rate is higher than the discharge. And that is very dangerous because of overflooding of the basin. At this stage, we already can decide, do we use or did we get right data from our customer or not? Or can we make some suggestions to him? So what we want to do at this point before we go forward with the complete calculation of the pump is to judge, has the basin the right size or not? Or can we suggest to the customer or tell him, please make your basin a little bit bigger or smaller or whatever? Or please take care of the inlet flow rate or of the outlet. Or probably we need to use a bigger pump. If the customer requires 200 cubic meter per hour, of course, this will not really work because the switch on and switch off numbers after the initial start is already free. That means 4 times the pump will switch off and switch on within 39 minutes. And this is, from today's point of view, still prohibited. So let's continue. After calculation of or checking the basin, we decide to have data which are usable without any problems. So then we start to fill in all the relevant system data. Let's start with the pipe legs from the pump to the next basin. We select, as example, 50 meters. So here we can also add a positive head if the piping is rising, or a negative head if the piping is dropping down. I think we will calculate with a positive head about 30 meters for our calculations. So the most relevant data we need for the calculation in spikes will be filled in here. So we can say the nominal diameter can be example DN 80, or can also say 3 inch. So why is it important to talk about the inner and about the outer diameter? We will see later on. So the type of the pipe can be selected here according to several codes and regulations. We can even select the material for the pipes, and then we can add how many bends, elbows can be considered in the calculation. Do we have to consider any shut-off valves or check valves in that system? All this info or all this equipment will have finally impact on the frictionless calculation and what we have seen here on the total delivery head of the pump. So that means in that case, if we are out of the maximum head of the pump due to some wrong data here, then we need to select a bigger pump, or Spikes will recommend a bigger pump. And probably, as we have talked, as mentioned already, either the pump is too big or too small. So I would say, let's have a look to Spikes and try to do the calculation. So first of all, I want to select a 3-phase pump. for general drainage, and we want to do the calculation quickly. So, and my favorite pump is still the KTZ. And we want to use drainage water with a density of 1,100 kilogram per cubic meter. We said the flow rate is about 60. The delivery head is about 30 meters. So, and these are the main data we need for the friction loss calculation. So once again, we need to add 30 meters. So, and at this stage, the system already selected a nominal diameter for the pipes with in DN 65. So what could be the reason to refuse to use this nominal diameter? It's quite easy. It's the high flow velocity. The flow velocity should be always around between 1.5 to 3 meter per second. This is a very rough indication or very rough numbers, but this can be about 3 meter per second, could be a little bit too high. So, but we said we want to use a 3-inch pipeline. So in order to make the calculation very easy, I will select piping. So, and I will also hide elements we do not need. So, and we said the pipe lengths between the both basins are 50 meters. So then let's check what will the system select, what kind of pump will be selected from spikes. So the KTZ 415, I think that's a good choice because the best efficiency point we can see here, our duty point is around is at 60 cubic meter per hours, and we still have enough reserve for some changes in the system. So let's jump back to our Excel sheet. So once again, I need to change 60 to 60 cubic meters. So, and there is no alert for the switch on and switch off intervals. That means this system can at this stage work without any problems. But let's have a look in spikes. What will happen if we select the wrong piping? I know we already discussed this already in our last webinar, but this is a very important topic. I think it's worth to discuss once again and once again. You can see here the 3-inch piping with the inner diameter of 80 millimeters. This 80 millimeters cause an additional head or friction loss of 9.438 meters. So what will happen if we change this to 65? So that will happen. The pump is completely out of the maximum performance curve. That means this pump will not work, or that system will not work. So if you got information from your customer, we have a 3-inch piping considered in our calculations without knowing the inner diameter of the piping, and we select the pump as we always do, and after installation that system will not work only due to the smaller inner diameter. This is once again for you all very important to have this info. So I think we are coming to the end of the webinar. First of all, thank you for your participation in that webinar. Our sales department is going to share with you an extract of that specification tool as a PDF file, which you can or should use as a communication form in all directions, with your customers, with your partners, and especially with us. The main message today is, if we talk about projects or pump selections or whatever, please try to get information as much as possible from your customer. Then we can do or help you to do the selection and the calculation. And we will give you the opportunity to argue against your, or to your customer or to your partner or to the end user, to make the right decision. So that's it for the moment. If you need more information, or if you want to have additional training on that topic with that tool, please feel free to send an inquiry to our sales department. And then I think we will have the opportunity to go deeper in that topic. So let's have a look on the questions. Okay. Any open questions? No, all questions was answered. Good. So that brings me to the end. Thank you for participating, and wishing everyone a relaxing and very nice weekend. Thank you. Bye-bye.